In this lesson, you will learn to use the angle-angle postulate and the side-side-side and side-angle-side similarity theorem. Now we've learned with congruent triangles that we have different postulates or theorems that we can use to show that we have congruent triangles. Like we had the side-angle-side, we had the angle-side-angle, angle-angle-side, etc. Same concept here with similar triangles, where we know that to prove that two triangles are similar, that we need to have all of the sides being proportional, and we also need all of the angles to be congruent. However, there are shortcut ways that we can use to prove that two triangles are similar. And we'll find that if we only know two angles to be congruent, then we have similar triangles. So that's what the angle-angle similarity postulate says, that if we have two angles of one triangle congruent to two angles of another triangle, then the triangles are similar. So this is a postulate, meaning we do not need to prove this. Okay, this is just kind of common sense if you were to think through this. And here we have four different triangles, and these are all similar. And notice that for each of these, the angles are going to be the same. This angle is congruent to this angle, which is congruent to this angle, and it's congruent to this angle. And then these two angles are congruent, and then this one is also congruent, and this one would be congruent as well. And then the top angle would be congruent with all of the other top angles. So all of these, because we have the angles being similar or congruent, we therefore have similar triangles. So technically, we need all three angles to be the same. But if we know two angles are the same, then by logic, the third angle must be the same as the other third angle as well. So all we need is two angles being similar. And here's an example where we have a 90-degree angle and a 90-degree angle. And we have 40 degrees here and then 50 degrees here. Well, with a triangle, we have 180 degrees total. If we have 90 here, that means the other two angles need to add up to give me the other 90, because 90 plus 90 would give you 180. So this angle up here would have to be 50 degrees. And notice that we have the right angle and then this angle that are congruent with the right angle, and then this angle for the other triangle. So because we have two angles that are congruent, we do have similar triangles. And also because we have two angles that are congruent, then this third angle would also be 40 degrees, same as over here. So yes, these would be similar, and that's because of the angle-angle postulate. Here's another example where we have two triangles, and we see right off the bat that these two bottom left angles are going to be congruent. And the question is, do we have another angle that is congruent with another angle for the other triangle? Well, if we know there are 180 degrees total in a triangle, here we've used up 60 and then 61. You add those to give me 121. So if you subtract 180 from 121, or by 121, then we're going to get 59 degrees for the third angle. And notice that is what we have over here as well. We have 59 degrees and then 59 degrees for the big triangle. So because we have two angles that are congruent, we can therefore conclude that we have similar triangles. Now here's an example where we can use the postulate to try to find missing values. So the question is to find the values for x and for y. So notice we actually do have two triangles. We have the big triangle and then we have the small triangle right here. So if we were to look at both of these triangles, okay, so this one in red, and I'm going to redraw the big one down here. Okay, now notice that we have one angle that is congruent. So this angle is congruent with the bottom left angle, which would be down here. And then the top angle, right up here at this vertex, is shared with the small triangle as well as with the big triangle. So this angle right there is going to be congruent to this angle for the big triangle because it is the same angle It's just being shared with the two triangles. So look at what we have. We have two angles that are congruent with two angles for the small triangle. So we do have similar triangles because we have two angles that are congruent. Now with similar triangles, as we learned, we can find unknown values by looking now at the scale factor. So we have 4 is the length of the left side of the small triangle, and then the left side of the big triangle would be 4 plus this other 2, which gives me 6. And then we have y for the length of the small triangle, and then for the big triangle, this length over here would be y plus 3. And then at the bottom we have x. Now the question is, since we know that these triangles are congruent, what is the scale factor? Because once we have the scale factor, then we can find our unknown values. So the scale factor is determined by looking at two corresponding sides. So looking at the left side, we have a 6 for the big triangle and a 4 for the small triangle. So my scale factor, comparing the big triangle to the small triangle, would be 6 to 4, which could reduce to give me 3 over 2. Now for solving purposes, it does not matter if I reduce, because 6/4 is the same thing as 3 over 2. So in this case, I'm just going to leave this as 6 over 4 when I solve. But since we know the scale factor is 6 over 4, we can then use that to find x and to find y. So looking at x is the bottom of the big triangle. Notice that corresponds with the bottom of the small triangle, which is going to be the 6. So I know the scale factor is 6 to 4, and that scale factor is going to be the same when I look at any pair of corresponding sides. So I know 6 over 4 would be the same fraction I get if I compare this big triangle, the x, with the small triangle, the 6. So 6 over 4 would also be equal to x over 6. That ratio will be the same. So now I have a proportion that I can then solve by cross multiplying. So I cross multiply. 6 times 6 gives me 36. 4 times x gives me 4x. So 36 equals 4x. I can then divide both sides by 4, where now I have x equals 36 over 4, which would equal 9. So x equals 9, and then I can solve for y as well. So once again, I'm going to use the scale factor of 6 over 4, where I know if I were to find the ratio of the big triangle, this y plus 3, to the small triangle, the corresponding side of y, if I were to divide y plus 3 over y, I will still get 6 over 4. So here's my second proportion. I can then solve this by cross multiplying, where I have 6 times y equals 4 times the entire quantity of 3 plus y. So I have 6y equals 4 times 3 plus y. So to solve this, I then need to distribute 4 times 3 and 4 times y to get 12 plus 4y. Solve for y by getting y on the same side. So I can subtract 4y to bring it over to the left side. So that will cancel. 6y minus 4y, I'm left with 2y equals 12. And then divide both sides by 2. I now have y equals 6. So I've used the angle-angle postulate to show that we have similar triangles, which then allows me to find the missing side lengths using the scale factor. So we have the angle-angle postulate that we can use, but there are also two other theorems that we can use as well to determine if we have similar triangles. So the first one uses the fact that we have two angles that are congruent. The second one we're going to talk about uses the fact that we have three sides that are proportional. Okay, so if we know that all three sides are proportional, then we also have similar triangles. And that is what the SSS, or side-side-side similarity theorem, says. Now yes, it is a theorem, which means that we technically do need to prove this. However, in this video, I'm not going to take the time to go through the proof. I'm just going to show you how to use this theorem. So here's an example, and you're trying to determine if you have similar triangles. And this one will be the side-side-side theorem, and let me explain to you why. So notice if we look at the corresponding sides, the 9 and the 6, the 12 with the 8, and the 10.5 with the 7. If I were to divide 9 by 6 and to determine the ratio of those corresponding sides, 9 over 6 would reduce to give me 3 over 2. Okay, so that is the ratio of AC to XY. And then looking at the bottom sides, we have 12 over 8. So 12 over 8 could reduce, divide the top and the bottom by 4. We have 3 over 2 as well. So far so good, but we need to have the third pair of sides having the same ratio as well. So if I take 10.5 divided by 7, this one may be not quite as obvious, but to get rid of the fraction, I can actually multiply first by a 2, which would give me a 21 over 14. And now this is easier to simplify. I can divide the top and the bottom by 7, which gives me a 3 over 2. And if you don't see that right off with a decimal being in the fraction, you can use your calculator to determine that the ratio for each of these would be 3 over 2 or 1.5. So because every pair of corresponding sides have the same ratio of 3 over 2, then I can conclude that we do have similar triangles. And we have similar triangles because of the side-side-side theorem. Now when you write that we have two similar triangles, just make sure that we are pairing up the corresponding vertices together. So if I said triangle, and let's say ABC, is similar to the other triangle, well, the A corresponds with the X. The bottom left corresponds with the other bottom left. And sorry, that should be a triangle, not an A. Similar to triangle, and then this should be an X because the A corresponds with the X. The B corresponds with the Z, so the next letter needs to be Z. And then the third letter, the C, corresponds with the Y. So I would say that triangle ABC is similar to triangle XZY. So it doesn't matter the order in which I write the first triangle, but when I write the second triangle, make sure that the corresponding vertices are paired up with the vertices of the first triangle. Here's another example, and we see that we have two sides that are the same as two sides of the other triangle. And the question is if we have similar triangles, and if so, to name them, and then what postulate or theorem justifies our answer. Well, in this case, we only have two sides given to us. So this side and this side, if those are corresponding, the ratio would be 5 to 5, or 1 over 1, or just 1. And then the ratio of this side to this side would also be 5 over 5, which would also equal 1. But I do not know this third side down here. So because I do not know that third side, I cannot conclude that I have similar triangles. Now it could be similar, but we don't know for sure. So there's no conclusion that can be made because only two sides are proportional and not all three. So now we've talked about the angle-angle postulate, the side-side-side theorem, and lastly we have what is called the side-angle-side similarity theorem. And so once again, this is a theorem, but in this video I'm not going to walk you through the proof. I'm just going to walk you through how to use this theorem. And the theorem says that if we have an angle of one triangle that is congruent to an angle of another triangle, and the sides that include those angles, meaning the sides on both sides of the angle, they must be proportional. If that is true, then the triangles are similar. So here's an example. We have two triangles, and notice we have one angle that is congruent with another angle. And then we have the sides on both sides of the angle, and we have two sides over here on both sides of this angle. Now looking at this, we need to determine, are the corresponding sides proportional? So here, if we pair up the 6 with the 8, if those are corresponding, we would have 6 over 8, which could reduce to give me 3 over 4. And then if the 9 corresponds with the 12, then I have 9 over 12, which could reduce as well to give me 3 over 4. So notice that the two sides that are next to this angle are proportional to the two sides over here that are next to this angle. So because of that, we have a side and then angle in the middle and then a side. So we have the side angle side similarity theorem that says that these would be similar. So make sure that when you write this, that the corresponding vertices match up with each other. So when I write that we have similar triangles, we have triangle MKL, and those vertices pair up with the N, and then the K pairs up with the P, and then the O would pair up with the L. So the order does make a difference. Make sure that you have the vertices paired up appropriately. And so this would be similar because of the side angle side theorem. And by the way, some of these might get a little tricky where you have to maybe experiment with pairing up different sides. So if I did not pair up the 6 with the 8 the first time, I might have tried the 6 with the 12 and find that we have 1 to 2, and then pair the 9 with the 8 and we get some other ratio. So if we find that we don't have similar ratios with the different sides, we might need to trial and error and pair up the different sides differently. And that concludes our lesson for today. We will see you next time.